Well, hello 2D. Now, this is not a formal lesson. I don't want you to take any notes on it. I just want you to sit and listen and try to understand what I'm saying to you. We're going to start into our work with primary trig ratios. And the primary trig ratios deal only with right angle triangles. Now, the first thing that I want you to think about here, I have two right angle triangles on the screen. The first one is possibly the most famous right angle triangle that we have, which is the 3, 4, 5 triangle. And the second right angle triangle I have here, I made just by making this one 2 times bigger. So it is just twice the size, so its side lengths are 6, 8, and 10. So hopefully you can agree with me that these are actually similar triangles, that this angle down here is the same as this angle there, and this angle up here, those two x's match up and the two right angles match up. So they've got 3 of the same angles, so they're definitely similar triangles. And you can see that these sides are all just multiples of the other sides. So now the first thing that I want you to think and make sure that you understand is that I can make these triangles as big as I want, and I will have another similar triangle that has this same angle in it and this same angle in it. Okay. So any triangle that I can make, any similar triangle that I can make to these things that have this angle in it, whatever that angle is, we don't know the number of that angle, whatever this angle is, um, will be similar to any other right triangle that has this angle. Now the reason for that is 90 degrees is already taken up here. And so if one angle is the same as the other angle in the triangle, then automatically the third one is the same by angle sum of a triangle theorem. So once we have that, then we just have to figure out what it means by ratio, because I haven't given you a ratio before now. A ratio means something divided by something else. And so in this case, when we talk about the trig ratios, it means a side of a right triangle divided by another side of a right triangle. And so I'm going to introduce a little bit of terminology for you here. This, from this angle, we're going to call this side over here opposite, because it is directly across the triangle from the angle we're talking about. This side length here is called the adjacent. Adjacent means right next to, which means that it's touching. So we've got opposite and we've got adjacent. And then this side here is across from the right angle. So the same as it was with Pythagorean theorem, we're going to call that the hypotenuse. Now that will be the same in any triangle we look at. If we switch angles, like say I wanted to talk about this angle up here instead of this angle down here, then this is the opposite side. This is the adjacent side because it's right next to that angle, and the hypotenuse stays the same. Okay. So that's the first thing that I want you to look at. Now we're just going to look at the numbers of these things. And we're going to deal with angle O. So I'm going to take the eraser and erase this stuff that I put on here. And we're only going to deal with angle O. So I'm going to mark on here the same as I did before. This is the opposite, this is the adjacent, and this is the hypotenuse. Now there's 3 special ratios in here. We're going to define them as this. I'm going to define my first ratio as the opposite side divided by the hypotenuse. I'm going to define my second ratio as the adjacent side divided by the hypotenuse. And I'm going to define my third ratio as the opposite side divided by the adjacent. Now, each one of these ratios also has a flipped over version. Those are called the secondary trig ratios. We're only going to deal with the primary ones now, so we don't have to worry about the reciprocal, the flipped over version of these ones. That's not something that we care about because it pretty much does the same thing. Now, these 3 different ratios have a name, but I want to convince you that it doesn't matter how big the triangle is. If it has the same angle, then these numbers, these divisions, are all going to work out to be the same thing. So in this case, let me just scroll up a little bit here, extend the page. For the first triangle, we're going to do this twice. For the first triangle, the little triangle, if we look at the opposite side, it has a 4 on it, and the hypotenuse has a 5. So in the little triangle, it's 4 divided by 5, and 4/5 is 0.8. If we go over and look at the bigger triangle, the opposite side is 8, and the hypotenuse is 10, and when we divide those, we get 0.8. So this one here is actually just the lowest common, or the lowest terms version of this one. Okay. So you see that it doesn't matter the size of the triangle. If it's got an angle the size of this angle O in it, then that's going to give you 0.8. So the ratio is always going to stay the same. And that's the same for these ones over here too. The adjacent divided by the hypotenuse is 3/5. And over here it's 6/10. And hopefully you can just see that 6/10 reduces down to 3/5, or you can plug it into your calculator and you'll get 0.6 for both of them. And then over here, opposite over adjacent. Going from the angle O, opposite is 4, adjacent is 5, so we get 4/5. Oh, wait a minute, not 5, sorry. Opposite is 4, adjacent is 3, so we get 4/3, which is 1.3 repeated. And in the other triangle, we have opposite is 8, adjacent is 6. 8/6, you can see, is just the multiple of that. And if you plug it into your calculator, you'll get 1.3 as well. So it doesn't matter how big the triangle is. If it has an angle the size of this angle O in it, the opposite side and the adjacent side will always divide to 1.3, and so on and so forth. Now we do actually give these three ratios a name. The name of opposite over hypotenuse is called sine. It looks like it says sin on your calculator, but we do pronounce it sine. Adjacent over hypotenuse is cosine. And again, you'll see that as cos on your calculator. And opposite over adjacent is tangent. And on your calculator, you'll see that as the tan button. And so that's a quick overview. Well, in the next video, we will learn how to actually use these things to find out more information about the triangle.